water it is
addition of solvent basically, and
yes,
in
sorry,
general
addition
we
of
call it
solvent.
water because generally we use water as solvent.
Yeah.
That's okay. And
Yes,
what
sir.
is concentration? If you are going to increase the concentration, that means you are going to increase the number of solute particles,
Solute.
of solute.
Yeah, yeah. Yes, sir.
So see what happens here. We are studying about conductance. Conductance. So first of all, there are two types of electrolytes. Just erase this conductance. We are going to study about electrolytes. Do you know how many types of electrolytes are there?
Electrolytes.
Yes, it is of two types, strong and weak.
Yeah, strong and weak. Yes,
From
sorry.
class 11, it is a strong one is a strong electrolyte and another is weak electrolyte, right?
Yes, sir.
So you can see. Have you written this topic?
Yes, sir. Yes, yes. I wrote last class only.
Okay, so this is two types. There are two types of electrolyte: a strong electrolyte and weak electrolyte. You know what happens in a strong electrolyte? Basically, here complete dissociation takes place. Complete
Dissociation.
takes place. Complete dissociation, or you can say 100% ionized. 100% ionized. That is called a strong electrolyte, like a strong acid, either a strong acid, a strong base, and also salts that are 100% dissociated almost. That is called a strong electrolyte. And what is weak electrolyte? This is basically partially dissociated. Partially dissociated. Partially dissociated. Or we can say partially ionized. Partially ionized. Are you getting my point?
Yes, sir.
So basically, we can take example here: weak acid, weak base, weak acid,
Weak base.
weak bases, or we can say basically we can say organic acid and organic base. Organic acid like ethanoic acid, methanoic acid, and organic bases like NH3 and all. Are you getting my point?
Yes, sir.
So these are all basically weak electrolytes, and these are a strong electrolyte. Okay.
Yes, sir.
Please write it. Then we are going to talk about conductance.
Yes, sir.
I need to take an extra glass of yours. Can I? When will you be free?
Sir, I don't know because I have unit test from next week.
Okay.
And I have school, so I don't know what.
So when is your school off?
Sir, Friday and Saturday, but Sunday I have my test, right?
Okay, no problem. So can we have?
Yeah, I think we can. Yeah, we can have on Friday.
Friday, right? Okay, in day we can take class, right?
Yeah, Friday you can take class, sir.
Okay. I was thinking that I should take class because your examination is also there.
Yes.
Please let me know when you are done with this.
Yes, sir.
Are you done with this?
Yes, sir. Done.
Okay. Now see, we are going to talk about conductance. What happens when you are going to dilute the solution? So see what happens. What will be effect? You know what? For electrolyte, the effect on conductance due to dilution is different from a strong electrolyte. From weak electrolyte, they vary. The variation basically takes place. So if you are going to dilute the solution, dilution increases. What does it mean? Can I write the concentration decreases? Yes or no?
Yes, sir.
So if you are going to dilute dilution, if there is dilution taking place, that means concentration decreases and also volume increases. Yes or no?
Yes, sir.
And if volume increases, that means the particles present in the solution will be far away from each other. That means force of attraction between the particles will be lowered. The force of attraction
Yes.
between
Yes,
the
the force of
particles
attraction
will
will
be
be
lessened.
lower.
So they can move faster than earlier. That means conductance increases.
Yes, sir.
So see, this is what's gonna happen in case of a strong electrolyte as well as weak electrolyte, but the variation of conductance is different for weak as well as a strong electrolyte. Is that clear?
Yes, sir.
So what I told you for electrolyte is partial dissociation. That means basically there is only 10%, 25%, 30% dissociation takes place in weak electrolyte. So this is what we are gonna do. If you are going to dilute the solution, that means concentration decreases. Just don't write it and focus on here. But
Yes, sir.
okay.
Yes.
And if dilution takes place, that means volume increases. That means basically force of attraction between particles decreases. Yes or no?
Yes, sir.
That means conductance increases. Are you getting my point?
Yes, sir.
Now see what happens. Since this is weak electrolyte and there is partial dissociation initially, but due to increment of volume or due to this dilution, force of attraction decreases and new ions introduced. New ions introduced. That means basically the breaking of or the producing of ions or ionization of ion is more than earlier. Are you getting my point?
Yes, sir.
Just suppose initially there were 5 ions that was due to that due to which conductance takes place. But if you are going to increase the dilution, these 5 ions converted into 15 ions. That means basically electrolyte produces 10 more ions. Okay, are you getting my point?
Yes, sir. Yes, sir. Yes, sir.
So if 10 more ions, that means conductance will be very high as compared to the earlier.
Yes.
Now, see about a strong electrolyte. A strong electrolyte.
Electrolytes.
So, same. That means basically, if you are going to dilute the solution, if you are going to dilution, if there is dilution taking place, that means basically concentration decreases, and that means basically volume increases. That means force of attraction decreases. And you know that a strong electrolyte already 100% ionized. So
Yes.
conductance, there is no more ions that you are going to add due to, there will be no more ions, addition of ions due to dilution because it is already dissociated into 100% and conductance increases. Are you getting my point?
Yes, sir.
Now see, what my question is, where will be the variation of conductance will be more? In which? A strong electrolyte or weak electrolyte? Weak electrolyte or a
Variation of
strong?
conductance.
Yes, variation of conductance. Initial and final. That
Sir,
means
the weak electrolyte, right?
weak, because there will be introduction or we just introduced new ions. There is production of new ions. That's why the variation of conductance in weak electrolyte is more
Yes, sir.
as compared to a strong electrolyte, because
Yes, sir.
strong electrolytes are already 100% ionized. What
Yes, sir.
happens here? Only force of attraction decreases. That's why the movement of ions is faster than the earlier. But in case of weak electrolyte, we just introduce more ions due to dilution. Got it?
Yes, sir.
Please write it.
Yes, sir.
Study as much as you can.
Done, sir.
Now see, whatever I just are you there?
Yes, sir.
Okay, please write this.
Yes, sir. Just right.
On diffuse.
Done, sir.
Am I audible?
Yes, sir. Now you're audible.
I'm gonna write a point. Please write with me, then I will explain.
Okay, sir.
What is conductivity? So basically, conductance due to all the ions, conductance due to all the
All the
ions
iron.
present in 1 ml electrolyte. 1 ml electrolyte. That means volume is constant here, 1 ml electrolyte. So basically, conductance due to all the ions in 1 ml electrolyte is called conductivity, that we denote with kappa. Now see what happens if you are going to increase the dilution. That means if you are going to add water or solvent, what happens here? Volume increases, and if
Yes.
volume increases, density will decrease or not? Decreases, because
Yeah.
density is inversely proportional to volume. That's why here conductivity decreases. Conductivity decreases on dilution. Are you getting my point?
Yes, sir. Yes, sir.
So whether it is weak or a strong electrolyte, whether it is weak or a strong electrolyte, conductivity decreases. Conductivity
Decreases.
decreases. It's very easy.
Done, sir.
Very good. since we just covered conductance and conductivity, now we are going to cover molar conductivity. That means lambda m and equivalent conductivity. Are you getting my point?
Yeah. Yes, sir.
So see, lambda equal. So you already know that lambda m is equal to kappa into 1000 upon m. That
Yes,
we
sir.
had studied in the previous class. And lambda eq is equal to kappa into 1000 upon m. Yes or no?
Yes,
And
sir.
here we are diluting the solution. Yeah, what we are doing, diluting it. That means, do you know what is molarity as a formula? Number of moles of solute upon volume of solution in liter.
Yes, sir.
If dilution takes place, that means volume increases. Yes or no?
Yes, yes.
If volume will increase, what will happen to molarity? Can you tell me?
If volume increases, what will happen to molarity?
Yes, increases or decreases.
It will decrease, right?
Yes. Why are you
It will
thinking too much? It is
Yeah, it
inversely
will decrease.
proportional. It will decrease.
Yes,
That
yes,
means
sir.
on dilution, molarity decreases. Now see, if you are going to increase the volume, that means kappa will increase. Oh, wait a minute. Okay. Wait a minute.
Yes, sir. Yes.
Okay. If molarity will increase, what will happen to this conductivity? It will increase because they
Yes.
are inversely proportional. Now, as you know that due to dilution, we just studied, kappa decreases. Yes or
Yes.
no? Here,
Yes, sir.
conductivity decreases. If kappa decreases, molar conductivity also decreases.
Yes, yes.
Are you getting my point? Because lambda m directly proportional to conductivity, molar conductivity directly proportional to conductivity. Are you getting my point
Yes,
or
sir.
not?
Yes, yes, sir. Yes. Molar connected direct proportional
Here,
connectivity.
yeah. What I'm asking, what we are gonna find here? What happens if dilution taking place? What will be the value of lambda n? Whether it will increase or decrease? Are you getting my point?
Yes, sir.
So experimentally, we found that this molarity is dominating on kappa. That's why lambda m increases. Are you getting my point?
Yes, sir.
As you know that due to dilution, lambda m decreases. That means molar conductivity increases. But due to
Yes.
dilution, kappa decreases. That means it also decreases. But molarity dominating kappa conductivity. That's why lambda m decreases. Are you getting my point?
Yes, sir.
In the same way, you know that normality has number of gram equivalent upon volume of solution in liter. Yes or no? This has a formula, normality in solution chapter we covered.
Yes.
Now volume increases, this decreases. That means if this decreases, this will increase.
Yes.
Yes or no? And
Yes.
you also know that with dilution, kappa decreases. That means this also decreases. But experimentally, we also find that normality is dominating kappa. That's why equivalent conductivity increases. So what we concluded here is that dilution in weak electrolyte is the variation is very more than a strong electrolyte. But when we talk about conductivity, with dilution, conductivity decreases in both cases. And in this molar conductivity and equivalent conductivity, with dilution, molar and equivalent conductivity both increases. Is that clear?
Yes, sir. Yes, sir.
Please write it.
Done, sir.
Very good. Now see, I'm going to plot a graph.
Okay.
You know what happens? This is the graph between C raised to the power 1 by 2, or we can write under root C, concentration, and its unit will be mole per liter raised to the power 1 by 2. Here it is 0.2 and here it is 0.4. And also this is 200 and this is 400. And this is lambda m, molar conductivity, Siemens centimeter square per mole. Now see what happens when we are going to talk about variation. The variation is like this in weak electrolyte. This is for CH3COOH, which is organic acid. But when you are going to talk about this the strong electrolyte, it will be this is for KCl. Now see, what I want to tell you is that if we are going to move from right to left, okay, so you can see C is for molarity, concentration. Okay, is that clear?
Yes, sir.
Now you can see from 0.4 to 0.2, if we are going, that means concentration decreases, that means dilution increases.
Yes, sir.
So if you are going to see the variation in for white, you can see the variation increases drastically. But if you are going to see for this KCl, the variation was like here to here only. But if you can see in electrolyte, weak electrolyte, the variation is this much. The molar conductivity increases. Are you getting my point? If you
Yes,
are
sir.
going from right to left, concentration decreases, and concentration decreases, that means dilution increases, and with increase in dilution you can see the variation. Initially the molar conductivity has a value of weak electrolyte less than 200, but if you are going to do the dilution or decrease the concentration, you can see it goes up to 400. Are you getting my point?
Yes, sir. Yes, sir.
That's why you can see the variation is very drastically. And there is a equation lambda m is equal to lambda not m minus raised a into c raised to the power 1 by 2. This is known as Debye-Huckel's equation. This is known as
DV hackers. Equation.
Debye-Huckel's equation.
Yes, sir.
So please write it.
Yes, sir.
A is constant, depends on type of electrolyte. Lambda naught m is molar limiting molar conductivity. And this is only for the strong electrolyte. This is only for
Strong electrolytes.
a strong electrolyte, not weak electrolyte, because it is an equation of a straight line, and a straight line is only for this strong electrolyte. Debye-Huckel.
Done, sir.
Now we're going to start a topic which is very important for you coming exams. Overall,
Sir, just a minute, sir. Just a minute. 1 minute.
okay, okay. Right. Slide.
Yes, sir. Continue, sir.
Am I audible?
Yes, sir.
So see, what is this? This Colross law of independent migration of ions. And you know what? Previous equation is only for a strong electrolyte, but this is for a strong as well as weak electrolyte. For a strong as well as weak electrolytes. Are you getting my point?
Yes, sir.
Now you can see. This law states that, please write with me. This law states that the equivalent conductivity of any electrolyte, that means basically a strong or weak, any electrolyte at infinite dilution, lambda equivalent ionic conductivities of cation and anion given by the electrolyte at infinite dilution.
Done, sir.
Anyway, so see what happens here. If there is equivalent conductivity of any electrolyte. Wait. Yes, Harsh.
Yes, sir.
So you can see lambda not infinity. Lambda infinity, that means infinite dilution of this molar equivalent conductivity of electrolyte at infinite dilution will be equal to the sum of equivalent conductivity of cation and anion. Are you getting my point? If you
Yes,
have
sir.
an electrolyte, are you done with this statement?
Yes, sir. Yes.
So now you can see if you have equivalent conductivity of NaCl, what will be the value of it? You know that NaCl is dissociated into ions like Na plus Cl minus. Yes or no?
Yes, sir.
So what will be the value? Lambda equivalent of Na plus lambda equivalent of Cl minus. Is that clear?
Yes, sir.
So please write it. So can you write the value of this A2B3? Oh, wait a minute. A2B. Are you done with this? Can you write this A2B3? First of all, you need to break down this in your mind in this dissociated. Do you know whatever is here is cation by IUPAC according to IUPAC, and this is an ion. Are you getting my point? Are you there? Hers. Hers, are you there? Okay, no problem. Let me know.
So can you hear me?
Yes.
Yes,
Are
sir.
you there?
Yeah. There's some problem with the mic.
Can you dissociate this? Yes or no?
Sir, can you do it?
Yeah, see, according to I, you take the first one,
Yeah.
whatever we
And
write,
cation
an
and
electrolyte is cation and this is anion. So this
yes,
will be
sir.
cation and this will be anion. Now see,
Yes, sir.
what will be the charge? Whatever is the number here will come here, and
Yes.
whatever is the number here will come here. Okay, and now
Yes.
now we need to balance it. So what is
Yes.
the number of A2 here? So this is 2.
2,
And what is the number of 3?
3.
So this is how we are going to do it. So what will be the
Oh,
value of this vitamin? What is the value of vitamin? So this was basically 2A plus 3 plus 3B minus 2. So what will be the value? Lambda equivalent, and this will be basically A plus 3 and
yes, sir.
then
B
lambda
minus.
naught EQ B minus.
Yes, sir.
Are you done with this? Can you do
Yes,
this?
sir. Yes, sir. Yes, sir.
A3B2. Oh, wait a minute. A2B5 I'm going to make. You just need to first
Yeah, switch the values.
dissociate it.
Yes, sir.
A2B5.
Okay. So it will be A plus 5
Yeah.
and then plus B minus 2.
And you have to balance it like
Yes, sir. So it will be A2, 2A, and then 5B.
yes, very good. Very good. Are you done with this?
Yes, sir.
So you have to write equivalent. This will be for A plus 5 and then lambda equivalent, and this will be for B minus 2. Yes or no? So this is only in terms of equivalent. Now we are gonna talk about molar conductivity. Are you done with this?
Yes, sir.
Now, when we talk about molar conductivity is also same, but in here we have to balance like molar conductivity of NaCl will be equal to lambda m infinity of Na plus lambda not m infinity of Cl minus. Because you can see NaCl when you are going to dissociate, it will be Na plus Cl minus. Yes or no?
Yes, sir. Yes, sir.
Now, can you write the value of MgCl2? Can you write the value of MgCl2?
Just a minute, sir. So, sir, will it be Mg plus and 2 minus?
Yes,
Sir?
it will be MgCl2. It will be like Mg plus
Yes.
2Cl. Now, what is the that is important. Are you there, Harsh? Harsh?
So, can you hear me now?
Yes, yes, I can hear
Yes,
you.
sir. You
Can you hear
yes,
me?
sir. Yeah, I can hear you
And
now.
yeah, please do this. Now see what happens. Lambda m naught.
It will
This
dissociate,
will
right?
be
Mg
Mg
and
plus
then
2, and
yes,
then lambda naught m,
Cl
and
minus.
this will be Cl minus. But when
Yeah.
we are going to talk about this molar conductivity, balance it. If there is 2 mole of Cl minus, so we just need to multiply it with 2. Are you getting my
Okay.
point? We do
Yes, sir.
only in equivalent conductivity, but we need to do it in molar conductivity. Is that
Yes,
clear?
sir.
Very good. So if I'm going to ask you the value of lambda naught m, Al2SO4, Al2SO4 whole thrice, please let me know.
Okay. A2SO4 3. So it will be
First write it in your notes and then let me
yeah,
know.
okay. Yes, sir. Sorry. So also will it be Al3 plus SO42?
SO4 2 only.
SO
SO4 minus 2, no?
yes, sir, sorry, minus 2. Yes, sorry.
Please, that is good, but let me know the value of lambda naught infinity of Al2SO4 whole thrice. Like this. You
Okay.
just did this part only.
Yeah, I have to balance
Like
it,
you
right?
just
Yeah,
do
just now.
Al2SO4 whole thrice. So you have to see. This is Al plus 3, you told me, and this
Yes,
is
sir.
SO4 minus 2. And now you have to balance in this. You have to multiply it by 2 and
With
you have
two
to
and
multiply.
then 3.
Now,
Yes,
see
sir.
what happens here. This is L plus 3, but in case of molar conductivity, we have to multiply it by 2 because it is
2.
2 mole here and lambda
Yes.
naught m SO4 minus 2, and here we need to multiply by 3. Are you getting my
Yes.
point?
Yes, sir. Done, sir.
Very good. So wait a minute. Now, are you clear with this lambda m lambda EQ?
Yes, sir.
I'm going to give you a question about calculate lambda not m for CaCl2 and MgSO4 from the data given below. Ca plus 2 has a value. Wait a minute. I'm going to give the value like lambda naught m of Ca plus 2 is equal to 119. Lambda naught m of Cl minus has a value 76.3. And all are Siemens centimeter square per mole. Siemens centimeter square per mole. And then lambda naught m for magnesium plus 2 has a value 106 Siemens centimeter square per mole. Lambda naught m for SO4 minus 2 has a value 160 Siemens centimeter square per mole. Please let me know.
Yes, sir. Sir, I did the first one, sir. Sir?
Yes, tell me the answer.
271.6.
Very good. Siemens centimeters per month.
Yes, sir. Sir,
Yes.
the second one is 746.
746. Are you talking about 746? Did you tell me 746?
Yes, sir.
So this is basically lambda.
So the first one is correct, right? CaCl2 is correct, right?
Yes, lambda not m
Yeah.
for MgSO4. So it will be equal to lambda not m of Mg plus 2
Mg
only,
plus 2, yeah, 2 plus.
lambda not m. And SO4, we don't need to multiply it by with any number,
Yes, sir.
because if you are going to dissociate it, it will be 1 mole MgSO4.
Yes, sir.
Mg plus 2. This is plus 2 and this is SO4 minus 2. 1, 1. So we just need to multiply with 1 or not. You don't multiply, that is equal. But in case of CaCl2, you saw that this will be Ca plus 2 and this will be 2Cl minus. Yes or no?
Yes, sir.
Hmm. Please write it.
Yes, sir. Done, sir.
Very good. Now we are gonna solve this and this is marks sheet that will be updated in marks sheet. Let's take the question. I'm gonna do this. Tell me the new.
So you're lagging, sir. I can't hear you.
See, can you see a new screen?
No, sir.
You will see it right now.
Okay. Yes, sir. I can see it, right?
Wait a minute. You're gonna do this 12. Please write the question. And then 14.
So can you hear me? So
जी हर्ष, हाँ हर्ष, क्वेश्चन लिख लिया आपने? 12 और 13 14?
sir, actually I got disconnected, sir, after I did. Sorry.
Okay, 12 और Harsh, are you done with this question?
Yes, sir, done,
Can
done,
I
done.
slide it down?
Yes, sir, you can slide it down.
Okay. Please 15 and then 9. And it's not doing.
So you're lagging, sir, I can't hear properly.
This 4 question and send it to me.
So which four? Okay, 15. Okay, 9. Oh, okay, got it. Sir, can you just scroll up to question number 4?